large and complex coastal sediment system. There's a littoral cell within which sand and sediment circulate, which is the ebb tide shoal. It forms a sandbar outside the Golden Gate, and every year we dredge a shipping channel in that sandbar, which has an impact on the shape of the beach, as well as provides a potential source of sand for beach nourishment. So that's a relatively homeostatic system, although not completely by any means, and it is in flux, and there's a lot of science and work to understand it. But south of that Noriega Street is a divergence in the current. And south of there, you have scour that is taking sediment southward, and the beach is getting narrower, and you have an erosion hotspot in a location adjacent to the zoo and the treatment plant. So this is kind of the shorthand cartoon that we developed. And it's, from the standpoint of a coastal scientist, it's okay. It's pretty good, captures the major points. We work very closely with coastal engineers and geologists on it. But from the standpoint of the public, immediately they at least get the basics that are very, very hard to explain. This one is about the combined wastewater and stormwater facilities that prevent those coastal discharges. So this shows how they're based on the natural watersheds of San Francisco. Stormwater and wastewater goes downhill through storm drains, gravity fed to the pump station at the foot of Slope Boulevard through these storage and transport structures. And from that pump station is pumped uphill to the treatment plant where it is treated, and the treated effluent is discharged 4.5 miles out to sea through the Southwest Ocean outfall. This is how the system is designed to work. It treats the stormwater and wastewater to a very high standard and has succeeded in preventing the kind of coastal discharges that used to be commonplace. However, in extreme wet weather conditions, this system does continue to discharge about 7 times per year. It used to be 70 times per year. And to get to 100% is essentially impossible. You basically have to, the cost curve is near vertical. But these underground structures are designed to fill with stormwater. There's a 2-chamber structure that is able to remove the solids, and this gets a little icky, but very important piece of infrastructure and very important for coastal water quality. And then under the most extreme wet weather conditions, the primary treated wastewater and stormwater comes out through these outfall structures that you may have seen on the beach. But most people have seen those outfall structures, but they have not seen the underground structures that are really the guts of the work. And that's important, the guts of how the system works. That's really important because it is those underground storage and transport structures, the invisible infrastructure, the invisible part of the city that is actually driving the decisions in this process. It is actually what's at stake. So using those kinds of techniques to communicate with the public allowed us to get people to sort of walk a little bit in each other's shoes and understand that it cannot be an either-or proposition. We need to protect coastal water quality. We need to protect the public ratepayer investment in these facilities that are performing that environmental service for us. And so we need to find a way to find a way forward that balances a variety of different imperatives and needs in a very tightly constrained space. So through this public process, we came up with these 6 key moves, and I won't drag you through them now. I will just talk through a couple of the most critical ones for the erosion hotspot south of Slope. We did tackle all sorts of questions that were simply related to use and to open space and access and aesthetics, but the real linchpin of this is how we deal with the erosion south of Slope Boulevard. So this is the current Great Highway traffic pattern. The basic heart and soul of the Ocean Beach Master Plan is rerouting that traffic behind the zoo via Slope and Skyline Boulevards, improving the intersections that are the constraint. There's lots of traffic capacity on the roads, but the intersections are very poorly designed, and we can actually make this work very well. And in exchange for that, we pick up the opportunity to take a much more flexible approach to managing the erosion challenge with more space and fewer constraints on how we do it. And we also pick up the opportunity for a spectacular roadless coastal trail and coastal open space experience. So everybody loses something, everybody gains something, And in taking a more effective and low-profile approach to protecting the infrastructure that's there, we allow coastal access, we allow habitat values to work, and we create a spectacular amenity in an area that is now sort of a poor cousin of Ocean Beach. Frankly, people don't go there unless they're surfing the break down there, and those are the passionate users. And we can also provide more of the habitat for the snowy plover and for the bank swallow, which are the two threatened birds on this beach. So just to walk you through this sort of adaptive program, remember this idea of adaptation being this long-term, incremental, stepwise action rather than just simply one big, shiny project. This is the current condition, basically kind of a leftover of what was a parking lot built on fill and a roadbed built on fill when the Clean Water Program was built. This shows what we can do without changing anything about the road, but reconfiguring the parking away from the eroding bluff and providing a clear pedestrian access along the oceanfront. This is what we're calling phase one, which is likely to happen late next year, narrowing the road from 4 lanes to 2 using funds that were aimed at storm damage recovery from the 2010 storms. Originally they were going to try to replace the road in kind, but this allows them to create this interim condition. By then narrowing the road, you free up today's southbound lanes for the introduction of a coastal bike and pedestrian trail, as well as revegetation with native plants south of Slope Boulevard. This is all with the existing revetments still in place, all with the Lake Merced Tunnel. You can see down underneath the road there, note how big that is. You can stand 2 people up in it. It's huge. And then finally, with the road fully closed and the installation of a subsurface protective structure around that pipe, as close to the pipe and as low in space as you can get, so you can have that much more laid back shoreline profile. You allow wave energy to dissipate over a long period, over a long distance, rather than hitting a large vertical wall. Then you can restore the surface and provide a really first-class open space experience, with the understanding that storm surges will come over that pipe. That's the design charge there. And we will need to do periodic beach nourishment if we want to maintain a sandy beach in that area. But if we have our eyes wide open about what's possible, we can protect that pipe, get a lot more use out of its useful life, protect coastal water quality, but have a beautiful open space as well. So I'm just going to show you a couple images from our subsequent studies. We finished the master plan in 2012, and then we engaged 3 different technical studies to kind of prove out the concepts and develop the engineering in coastal management, in transportation, and in open space and planning. And I won't dwell on this. I'll just show you some quick images. Very importantly, the approach to coastal erosion, the way we sort of communicate with the public about this is, instead of are you for retreat or are you for armoring, it's no, there's a toolkit of 3 major tools and we need to use all of them. It has to be a yes and plan, not an either or plan. Manage retreat, do the closure of the parking lots and the road. Beach nourishment, using that available clean sediment that's being dredged from the marine shipping channel. And low profile structural protection, all working together with multiple objectives in mind. You're not just protecting a piece of infrastructure, you're also providing an open space. You're not just rerouting the traffic and making sure you have the capacity, you're making better streets and better places for the zoo, for the local businesses, for the local community members. So with that yes and plan in mind, we did a detailed analysis of the hazards, and I won't bore you with that. We determined that we could get much, much, much closer to the pipe than we had initially anticipated, which means we can create that low profile structure. The pipe is basically at beach level, which means that it can be that kind of speed bump that we envision and have a safe protected structure around it. And a good model for this, if you're familiar with Ocean Beach, is the Terravelle seawall, built in the 1940s just north of Slope Boulevard. It's basically at beach level too, although in erosive winters, low beach conditions, more of it becomes exposed. It does its job, and then when the beach recovers, it's actually invisible most of the time.